I'm going to talk about is maintenance beliefs or behaviors, or we call it beliefs. Belief 8, basic maintenance processes must be in place before implementing more advanced processes. So don't use technology or try to implement RCM before you're ready for it, because then you will change your focus too much on totally different things. You take away your focus from the very basic processes, like the work management processes and the chain I'm going to explain here, and then that will fall back. But if you're ready for it, and I will come back to that later here, then absolutely you shall use that. You shall use that. For example, as I said in the beginning, a lot of people are almost fanatic about RCM. And the training and other things is important there. But many times people will realize that they go through the training, and the training I think everybody should go through because we need to understand those things. But when it comes to implementation, they will see that they will never get through it. And I talk about manufacturing plants, right? And many have said it to me, are you shooting mosquitoes with a cannon? Because after time they just give up. So let me explain here. The core of reliability and maintenance management, keep it simple. The first step there is to prevent, which include precision alignment, precision installation, lubrication, fixed time maintenance where you can justify it in perhaps 5% of the equipment, operating practices, etc. Anything that prevent maintenance from occurring or failure from occurring. The next step is inspect. And the purpose of inspecting, whether that is with very advanced technologies like acoustic emission or with vibration analysis or many other well-known methods, including look, listen, feel, smell, which is still a very valid part of inspections. The purpose of that is to find a failure early, to catch it early, so a time will pass before you have to correct it, which gives you an opportunity to plan work, which means to decide what are we going to do, and then how are we going to do it, and estimated time. And then we can, after that, you have to plan first and then schedule. That is to decide when are we going to do it, and number two, who is going to do it, in that order. So you schedule not to the people you must have, just happen to have available, and then you execute. And if you do these things, you will have time to improve. In our definitions, prevent and inspect is preventive maintenance. The rest is corrective maintenance because you correct the failure. And that chain between inspect and execute must not be broken. And that happens very frequently. When you take RCM, for example, and you go into that, what you then focus on is really prevent and inspect. Because the whole RCM exercise is to find what is the right frequency, what is the right task to do in preventive maintenance. But it doesn't include plan, schedule, execute. John Mowbray in his first book didn't include that at all. So often we have to understand that RCM, for example, is a tool, and it's a very good tool, and it's good to have training in it, so we understand the principles of how failures develop and so forth. So when are you ready to take the next step? Well, one example is here. If you say that we have a process that every Wednesday or Thursday, for example, we set the schedule and we freeze the schedule on Wednesday or Thursday for all work we have coming up next week. And we have the schedule fully loaded. Not only that you say, well, in this area we have 22 people, but we only schedule for 12 of them. No, that you have to schedule for all of them. And if you then have a 30% compliance next week on that, that is very good. And then on a daily schedule, let's say today at 11 o'clock, we freeze the schedule for tomorrow. And tomorrow people come in and they can follow that to 90%. That's also very, very good. There are some exceptions to that, like in automation, electronics, where you have to actually go out when something happens. It happens like this, and you have to go out and troubleshoot and find out what's wrong before you actually can plan, get the right parts if you need that, and then schedule how to do the work. That's one part of exception there, but otherwise for mechanical and electric equipment, this is fine. And then for shutdowns, if you have those, depending on how big the shutdowns are, there you freeze the schedule 4 weeks or perhaps 2 weeks before the execution of the shutdown, and you should have 95% compliance. If you are in a situation like that, you are in a very controlled environment, and you're really ready to take the next step to add perhaps RCM on the very, very critical equipment that you don't understand fully how it's working. Rapid and sustainable change is not applicable in maintenance because the change process is 90% about people and behaviors. So you can't just go in there and say, we're going to turn around this maintenance organization. Give us 6 months, and you force all these processes in. You will see improvements, definitely. But when you leave, if you do this from an outside resource, or you do it from someone from corporate, or you do it yourself, no, it's going to fall back. Because it's 90% about people, and you need to give them time, and one step at a time, especially if you change from a very reactive organization into a more planned and scheduled and controlled environment. So remember this forever, because in conferences and training today and articles and so forth and books written in this area, it's very much about the latest technology, online sensors, AI in maintenance, all of it good stuff. Absolutely. But many organizations I have seen are not ready for it, and it takes away the focus from the very basics of maintenance, and then that falls apart. And that's not what you want to do. Operations, engineering, maintenance, and stores must work in a partnership to reach excellence. I've been preaching this for God knows so many years. I don't know how. I got these ideas on board the ship because there you operated, you maintained, and it was one crew. You were in a very contained environment. Everybody depended on each other, and it could be very critical if something happened. We could see that what happened in the Suez Canal some years ago when a ship got a problem and stopped world trade basically because of a problem. And I went through that canal, I think it was 6 times, and also Panama Canal. It was very tense to see to that nothing happened, right? But anyway, it should be a partnership in reliability, total reliability, manufacturing reliability, and not the finger pointing saying, who was at fault here when we lost production? No, we have to say, approach that in a different way, and I'll come back to that. So they need to work in a partnership. And you need to bring up all your processes based on that. So when you develop your work management process from initiation, from a notification or whatever you like to call it, work request comes in, where does it go? Always in mind, operations and maintenance are involved here. And perhaps when you have your meetings for scheduling work, it should be led by should be chaired by a person in the operations department. You should have a one point of contact between operations and maintenance in each area. So all jobs in that area goes to that person, who often is an operating person, and that person will then prioritize, see to that you have the right numbers, etc., on this. And many of you call it filters. And in big organizations, that's a full-time job. In smaller organizations, it's just one person in each area that does this as part of their job. But there are a number of things you need to do to see to that you get a true partnership with operations and maintenance. Lost production, therefore, shall record where and what, then ask what happened in order to solve and eliminate the problems. You don't ask, okay, we lost 4 hours of production yesterday. This happened in the manufacturing process. That was electrical. No, they said it was not electrical. Well, the motor tripped. Well, it didn't trip because and you have these arguments and so forth. Well, then it goes, no, it was mechanical. No, it was instrumentation. No, it was operating failure, and that kind of discussion. If you have that kind of a discussion, you break the first rule of root cause problem elimination. You jump into a conclusion immediately instead of saying, where did this happen? And then you ask yourself why. And perhaps you start with a why analysis first, just quickly, before you get into a more deeper root cause analysis. So you change from doing who to change why. That's more accepted by people. And remember again, we talk about people here, not just technology and other things.